we'll discuss about various gas laws. The first one is Boyle's law, and it is Robert Boyle who given a relation between pressure and volume at a constant temperature for a fixed mass of a gas. The relation is very simple. The law states that the pressure is inversely proportional to its volume at a constant temperature as well as for a given amount of the gas. That means the mass of the gas must be a constant as well as the temperature, so that the pressure is inversely proportional to its volume. Now, these are the mathematical relation. Pressure is inversely proportional to its volume, or you can say pressure into volume is equal to a constant, or you can say the product of pressure into volume at various conditions for a given gas at a constant temperature must be equal to a constant. That is P1 V1 is equal to P2 V2 equal to P3 V3 must be equal to a constant. Now we'll discuss the various method for the graphical representation of Boyle's law. So one is the pressure against 1 by V. If you taken the graph pressure against 1 by V, it will be a straight line graph because this is of the form P equal to K into 1 by V. Once again, P is equal to K into 1 by V. So that is of the form Y equal to Mx. Y equal to Mx is a straight line graph, and instead of the Y, here you have pressure, and instead of X you have 1 by V. It's a straight line graph with a positive slope equal to K. Similarly, V against 1 by P also is a straight line curve with a slope equal to K. Then you have pressure against volume. It is clear as the volume increases, the pressure goes on decreases. Similarly, volume against pressure. Now, if you taken the PV against V or PV against P, the product of pressure into volume will be a constant irrespective of the variation of pressure or volume. So PV against P is a straight line curve parallel to the pressure axis or the volume axis as you draw the curve. Now here we'll discuss the Boyle's law with an example. Here you have a gas, 2.5 liter of a gas at a standard temperature and pressure is compressed to 473 milliliter. What is the new pressure of the gas if temperature is constant? So since the temperature is constant and fixed amount of gas is there, we can make use of Boyle's law. Expression is P1 V1 is equal to P2 V2. The term V1 is equal to 2.5 liter, V2 473 milliliter. One is in milliliter, the other is in liter. So we'll convert the milliliter into liter by dividing by 1000. So it is 0.473 liter. P1 is 1 atm. So what is P2? That's the question. We'll substitute all the values and solve for P2, and we get the P2 as 5.29 atmospheric pressure. Now we discuss about the next gas law. It is Charles law. Charles law is a very simple relation, and it is a relation between volume and temperature. And it says the volume is directly proportional to temperature at a constant pressure for a fixed mass of the gas. So that we can write down V by T is equal to a constant, or V1 by T1 is equal to V2 by T2. Now we have a graph volume against temperature. So since it is of the form V equal to T into K, or Y equal to, here it is Mx, so it is a straight line graph. So it will be a straight line curve with a positive slope, and slope of course is equal to K. Now we plotted 4 different curves at different pressures numbered as P1, P2, P3 and P4. Now how these P1, P2, P3 and P4 are related? It is simple. here you have the volume. Volume is increasing. Volume is increasing from here to here, going upward. Since the volume is increasing, what happened? By moving from P4 to P1, the pressure must decrease because the pressure and volume are inversely proportional. So P1 is the least pressure, while P4 is the maximum pressure. So there is a relation between all these pressure and volume. Now we'll discuss about ideal gas equation. What is ideal gas equation? We have Boyle's law. V is inversely proportional to pressure and a constant N. N is the number of moles of gas and temperature. Similarly, Charles' law, volume is directly proportional to temperature and a constant number of moles and pressure. Avogadro's law, volume is directly proportional to number of moles. By comparing all these three, we get V is proportional to N into T by P, or we can say V is equal to a constant into N into T by P, and that constant is R, called the universal gas constant. So we can say PV is equal to nRT. So that is called the ideal gas equation, PV equal to nRT.